We've seen how to process big data in AWS and how to issue SQL queries against it interactively. But to really extract meaning from your big data, you need to visualize it with charts and graphs. That's what this next domain is about, visualization of big data on AWS. Visualization tools are aimed at a broader audience than AWS developers and engineers. We'll show you how Amazon QuickSight allows you to interactively explore your data with a wide variety of graph types and go hands-on to visualize the data we exposed through Redshift earlier. Effective visualization requires knowledge of how to choose the right kind of graph for the right kind of problem, and we'll spend some time to ensure you know which visualization type is appropriate for different kinds of data. Finally, we'll touch on some third-party visualization technologies so you can be conversant in how they compare to AWS offerings. Let's get started and learn how to visualize your big data in AWS. Let's dive into Amazon QuickSight, which is AWS's visualization tool for big data. What is it? Well, it offers, they say, fast, easy, cloud-powered business analytics service. And yeah, it's basically that. It's this service that's really geared toward end users. It's a very different kind of AWS offering, really, because it's not really made for developers. It's made for business analysts. And it's made for all employees in an organization, whether or not they're developers or programmers, to build visualizations or perform analyses or get business insight from data anytime on any device. So they can do this through a browser interface, from a mobile interface, what have you. So it's not your typical AWS thing where you're really thinking about it in terms of a computer scientist or an architecture standpoint. It's really an end user tool made for people who are just trying to extract meaning from the data that you exposed to QuickSight. And it is fully serverless, so you don't have to worry about how it actually works under the hood. You just have to know how to use it. QuickSight can sit on top of several different data sources, including Redshift. Also, it can sit on top of Aurora or RDS, and Athena as well. Also, any EC2 hosted databases that can communicate through JDBC or ODBC. And also, it can communicate directly with files stored on S3 or on your on-premises systems as well. So you can actually just stick QuickSight on top of some raw Microsoft Excel data. Remember that, guys. If you want to actually have a way of visualizing data in an Excel spreadsheet, QuickSight can do that. It can also sit on top of CSV or TSV data, or anything in common or extended Apache log format. QuickSight also has some rudimentary data preparation abilities as well that allow you to do some limited ETL operations on the data before you visualize it. So you can actually do things like, let's say you have a CSV file and you don't like the column names in the file. You could actually change those field names during the data preparation stage. You can also do things like adding in calculated files, issuing SQL queries to transform your data, or change the data types that were imported before you visualize it. An important piece of QuickSight is Spice, and this is its trick that it uses for accelerating its queries. Spice stands for Super Fast Parallel In-Memory Calculation Engine. So it's a way of copying your data from Athena into a more optimized format that leads to faster queries from QuickSight. So the idea is that it uses columnar storage, in-memory access, machine code generation, and the idea is to accelerate your interactive queries on very large data sets. Now, this does take space, of course, storage capacity. It basically needs to copy a lot of your data from Athena into this more compact and optimized representation that Spice uses. Every user gets 10 gigabytes of Spice by default. It is promised to be highly available and highly durable, just like S3 would be. And it can scale up to hundreds of thousands of users. So they've made it available, durable, and scalable. So the idea of Spice, again, is just to accelerate your queries, but it is an extra layer there. So you have to think about that sometimes. So although it can accelerate very large queries that would normally time out if you're using direct query mode is another word for hitting Athena directly, you can get into a situation where your queries are too big even for Spice. So one situation you might encounter is that if it takes more than 30 minutes to import your data from Athena into Spice, you're still going to time out. So even though Spice is designed to accelerate large queries with QuickSight, there's still an upper limit there that you might hit. So something to be aware of there. But just remember, Spice is the superfast parallel in-memory calculation engine that exists to give you a more optimized representation of your data and accelerate your interactive queries through QuickSight, especially on large data sets. But it is possible to get so large that even Spice can't handle it. Here are some of the use cases that Amazon recommends for QuickSight. One is the interactive ad hoc exploration and visualization of data. So you might recall that this is actually explicitly an anti-pattern in other services. However, QuickSight is designed from the ground up for ad hoc exploration and visualization of your data. You can also create dashboards with QuickSight, so you can make these nice to look at dashboards to visualize data on a periodic basis and make sure that your executives can see those and see how the business is doing. It's also useful for analyzing or visualizing data from a variety of sources, including S3 logs, any databases you might have on-premise, other AWS services that we listed earlier, RDS, Redshift, Athena, and S3. You can also integrate QuickSight with things like Salesforce, which might be useful to know. Any software as a service application can probably integrate with QuickSight, and any JDBC or ODBC data source. So pretty much any data source you can imagine, QuickSight can import it and allow you to visualize it very quickly and at large scale. However, there are some things QuickSight is not made for. One is a highly formatted canned report. QuickSight is made for ad hoc analysis and visualization, so if you want some really highly formatted, very detailed, tuned looking reports that have to have a very specific look and feel, QuickSight cannot do that. And although it has limited ETL capabilities, if you want to do more powerful or larger scale ETL transformations on your data, QuickSight really isn't the tool for that. You want to be using Glue ETL instead, or maybe Apache Spark. But again, QuickSight does have some limited transformations you can do just to make your data look a little bit better. From a security standpoint, it offers multi-factor authentication on the accounts that access QuickSight. Remember, this is more of an end-user tool, so you're not going to be using lower-level security features with this. It does have VPC connectivity, however, so you can add QuickSight's IP address range to your database security groups. You will have to worry about how QuickSight will communicate with your databases and get through the security you have on them. It also offers row-level security, or RLS, that enables QuickSight dataset owners to control access to data at row granularity based on permissions associated with the user interacting with the data. And with RLS, or row-level security, QuickSight users only need to manage a single set of data and apply appropriate row-level dataset rules to it. In late 2020, they also added column-level security, or CLS. This is only present in the Enterprise edition of QuickSight, but it does allow you to manage security at the column level as well as the row level now. You also have private VPC access available. That's made possible through the Elastic Network Interface, or ENI, to create a secure private communication with data sources in a VPC. That also uses AWS Direct Connect to create a secure and private link with your on-premises resources. So if you do want to use QuickSight on top of on-premises databases or files, you can use Direct Connect to do that. A little more on security in QuickSight. So how do you manage resource access? Well, it's pretty simple, really. Right from the QuickSight console, there's a Manage QuickSight menu, and from there you can go to Security and Permissions, and from there you can ensure that QuickSight itself is authorized to use Athena, S3, and specifically your S3 buckets. So before you get to the user level, you have to make sure that QuickSight itself is authorized to access the data that you want, whether it's in Athena or S3. And again, that can be managed right from the QuickSight console. Now, if you do need to restrict what users can access, specific users, you can create IAM policies to restrict what data in S3 a given QuickSight user can access. So remember, you need to ensure QuickSight itself is authorized to access your data, and you also need to control what users can access what data through IAM policies. So QuickSight itself, you can just manage that through the QuickSight console, but if you do need more granular permissions at the user level, IAM can be used for that. So there's also the specific issue of QuickSight and Redshift together from a security standpoint. And generally speaking, QuickSight just tries to handle all this stuff under the hood for you because it's really aimed more at end users and not AWS experts, but this is one area that can trip you up. So the thing is, by default, QuickSight can only access data stored within the same region as the one that you're actually running QuickSight within. So you could have a situation where you have an existing Redshift cluster running in some region like, Japan or something, but you actually spun up QuickSight in Virginia. And in that case, you're going to get errors because those two regions can't talk to each other. You might think you could just create a VPC and configure that to work across regions, but that actually does not work with QuickSight. If you do have this situation, the way to fix it is to create a new security group with an inbound rule authorizing access from the IP range of the QuickSight servers in that region. So I'm highlighting this for a reason, guys. Those ranges are fortunately documented. You have to look them up, but that is the step you have to take if you need to have QuickSight access a Redshift cluster that's in a different region. Set up a new security group with an inbound rule with the IP range of where the QuickSight servers are. And you got to look up what those IP ranges are. Talk a bit about QuickSight user management. How do you actually manage who has access to it? Again, AWS tries to make QuickSight end user friendly. So you can define users in IAM and just do it that way. That gives you more strict control over what individual users can and cannot access in terms of what data, what underlying S3 buckets, what Redshift databases, what have you. Or you can actually configure it so people can just sign up over email and get approved that way. So that's a more easy way to set things up if you're comfortable with it. Also important to understand is that there is Active Directory integration available in QuickSight as well. There's something called Active Directory Connector. This is only offered in the QuickSight Enterprise Edition. And again, in the spirit of making things as easy as possible, with Active Directory Connector, all the keys are managed by AWS for QuickSight. You cannot use customer-provided keys with Active Directory with QuickSight. Also remember, Active Directory support is only in the Enterprise Edition. Now what you can do is set up different groups of users that correspond to Active Directory user groups and tweak their security access using IAM if you need to. So you can still set up groups of users through Active Directory and tweak what they can and cannot access using IAM. So the takeaway here is the base starting point of security in QuickSight is IAM. You can use that to define what users can or cannot do. Email sign-up is an option. And if you're using Enterprise Edition, you can use Active Directory Connector, but remember the keys are all managed by AWS. You cannot use customer-provided keys, and it is only supported in the Enterprise Edition. So as we mentioned, QuickSight is a little bit unusual as AWS services go in that it is really focused on end users and not really so much developers, and its pricing model reflects that as well. So an annual subscription for QuickSight is based on how many users per month are using it. For the standard edition, that will cost you $9 per user per month. And for the enterprise edition, it is $18 per user per month. And obviously that can add up very quickly for a large organization. If the 10 gigabytes that comes standard with QuickSight for Spice capacity is not sufficient for you, you can purchase additional storage per user as well. For standard, that will come at 25 cents per gigabyte per user per month. Or for the enterprise plan, that will be 38 cents per gigabyte per user per month. And if you don't want to commit to a full year and an annual subscription, you can also do month to month. It is going to cost you more. For a standard plan, that's $12 per user per month. And for enterprise, $24 per user per month. So what's the difference between standard and enterprise that allows them to charge double? Well, two things really. One is that you get encryption at rest. So if you need to encrypt the results of your QuickSight dashboards and jobs, Enterprise Edition lets you do that. Also, it will integrate with Microsoft Active Directory. So if you have an enterprise that's built on Microsoft Active Directory, that allows you to integrate with that environment for authentication very easily. An important feature of QuickSight is dashboards, and if you've done any data analysis at all, you know what a dashboard is. Exactly what it sounds like. It's a read-only snapshot of your analysis that you can present in a graphical form to people, let them sort of browse through various important charts and graphs and numbers that are associated with what you care about, and present that all in a compact manner to your business owners so they can actually do something with that information. Dashboards, of course, can be shared with other QuickSight users. They do need to have QuickSight access, though, and be set up as users in QuickSight, because QuickSight does charge you by usage and who's using it. Now, in addition to looking at your dashboards through QuickSight itself, they also have something called embedded dashboards. So you can actually share these things even more widely within your own applications. So with embedded dashboards, you're given a JavaScript SDK and an API that lets you embed that dashboard powered by QuickSight into some application that you give people. Could be a mobile app, could be a web app, I don't know. But it's a way of embedding QuickSight dashboards into other applications. Now, how does that work? Like the main issue you might think of there is, well, how does QuickSight bill me for that? If QuickSight's based on usage and billing me on usage, A, how does it know who's using it? And B, how do I prevent everyone in the world from hitting my QuickSight dashboard through some app and me getting billed for everybody in the world? So there's a lot of authentication that happens to make embedded dashboards work. Now, in order to make it seamless, you can authenticate your dashboards that are embedded with Active Directory or Cognito or basically any other single sign-on technology that you might be using. So oftentimes it's possible to take the same authentication mechanism that you're using to authenticate access to the application that you're embedding the dashboard in and use that to pass along to authorization to QuickSight itself. And you do need to whitelist the domains where your embedding is allowed. So within QuickSight, you need to give it an explicit list that says, I'm going to allow embedding from these domain names from these applications. So that way, random people on the internet cannot access your dashboard and make you get billed for stuff that you didn't see coming. From an implementation standpoint, again, it has a JavaScript SDK for easily embedding these dashboards within any sort of web-based application. And there's also an API that it offers if you want lower level access, or if you want to embed this into a lower level app that's, going down to C++ or something like that, right? So there's a JavaScript SDK for quick embedding in web apps, but there's also an API to let you do this within pretty much any context that you can imagine as well. So that's dashboards. Not a lot to talk about with dashboards itself. It's exactly what you think it would be, but embedded dashboards have a few nuances to it that are worth knowing. You need to know about QuickSight's Machine Learning Insights feature. This is a relatively new capability, and it's coming up on the exam more and more. There are a few things that QuickSight can do using machine learning. So Machine Learning Insights, is just sort of a catch-all term for some of these different features that are in QuickSight. One is ML-powered anomaly detection. So it can use what's called random cut forest, which is a proprietary algorithm Amazon published that they're very proud of. And it can automatically identify the top contributors to significant changes in your metrics. So it finds outliers for you automatically. It tries to find things that are anomalies in your data set, and it can identify what those are. So if you need to understand what the outliers in your data set are and try to understand what's causing them and generating them, you can use ML-powered anomaly detection to try to identify what constitutes an outlier automatically based on machine learning. It can also do forecasting using machine learning. Very important to remember this, ML-powered forecasting. Under the hood, that also uses their random cut forest algorithm, but it's used to detect seasonality and trends over time. And the way that it works is that it automatically excludes outliers using random cut forest, and it can also impute missing values as well. So by using machine learning, it can take an incomplete or a messy data set and still forecast that while still preserving seasonal trends and longer-term trends as well automatically. So that's what ML-powered forecasting does for you. Another machine learning insight feature is auto narratives. Basically, it adds what they call the story of your data to your dashboards in QuickSight. An example of what that looks like is here in the slide. So in this example from their documentation, total revenue for November 17th, 2018 decreased by 2 whatever percent from blah to blah, and compounded growth rate for the last 4 days is blah, which was worse than expected. So it just allows you to translate your data into plain English. And, sometimes that's easier for people to consume than a graph or a visual. It allows you to interpret that data and do things like tell you, is this data good or bad, automatically using machine learning. QuickSight also has a Insights tab in its UI, and this gives what's called suggested insights. So if you hit the Insights tab, it can tell you which of these machine learning features might be relevant to your dataset and give you ready-to-use suggested insights to just look at and incorporate into your analysis. A more recent feature of QuickSight is QuickSight Q. Sounds very James Bondish, doesn't it? They advertise it as being machine learning powered, which it is, but kind of weird that they lead with that. Anyway, its idea is to answer business questions with natural language processing. So it now allows people to query QuickSight just using plain language, like what are the top selling items in Florida? And doing that's harder than it sounds, right? Like somewhere it needs to know that top selling means something associated with revenue, right? And what revenue field in my data does that correspond to exactly? So these sorts of queries that are very easy for humans to answer often aren't that easy for machines to answer. So this is actually kind of a challenging thing. QuickSight Q is offered as an add-on, and it's available per region. So some regions have it, some regions don't. You have to add it on explicitly to different regions that you care about. And something that's a little bit weird, at least right now, is when you sign up for QuickSight Q, part of the process is signing up for a one-day workshop with an actual person who tells you how to use it and trains you on how to use it. So maybe it's not quite as intelligent as it sounds. It actually requires a fair amount of hand-holding to get people to use it properly. Part of that might have to do with the audience. Like we said, QuickSight is really not aimed at developers so much, but it's hard to train a machine learning system if you're not a developer. So I think that's probably where that's coming from. What does that setup look like? Well, you need to configure what we call topics that are associated with your data sets. So those data sets and their fields must be NLP friendly. So if you want to be able to query your data sets using natural language, you need to make sure that your fields have titles that are what you would call them using natural language. So, some cryptic column name with a bunch of underscores and stuff probably won't work. You need to give those natural language sounding names first as part of setting this up. You also need to explicitly tell it how to handle dates. That ends up being kind of a complicated thing. But yeah, there's quite a bit of tweaking to your data that you need to do before QuickSight Q will work well. But watch this space. I'm sure it will evolve over time. Figuring out what visual type, what kind of chart or graph to use to convey a certain bit of information is really half the battle in using QuickSight, and the exam will expect you to know how to do that. So there are several different visual types available within QuickSight. Let's go through them and talk about what they're for, and then we'll go through some specific examples of usage of each one. Autograph is a cool feature of QuickSight. If you just select some columns of information in QuickSight, it will try to automatically figure out the right kind of visual to present that information. So it selects the most appropriate visualizations based on the properties of the data rather than you selecting one. And the visualization types it chooses are chosen to best reveal the data and the relationships in an effective way. So if you don't know what you want, try Autograph. It might just make the right decision for you. However, the exam will expect you to know how to make that decision yourself. So let's go through the other different types you can choose from. One is bar charts, and there are several variants of these, horizontal and vertical ones and stacked ones. These are usually used for comparison or distribution. So if you have different things where you're trying to compare the quantity of different things together, a bar chart is a good way to see them side by side and see how they stack up against each other. It's also used for histograms, where you're trying to bucket things together by certain ranges and see how those ranges of values compare to each other. If you're trying to show changes over time, a line graph of some sort is probably the right choice for that. And if you're trying to show the correlation between two or more attributes, a scatter plot or a heat map might be a good choice. I think everyone's seen a pie graph at some point, and together with tree maps, they are both tools for aggregation, showing how different components of something add up to a whole. Also for tabular data, if you just have 2D data and you just want to measure the values of intersection for 2 dimensions or apply statistical functions to them, or if you're dealing with multi-dimensional data, a pivot table is probably the thing for you. It's basically a way of manipulating and slicing and dicing tabular data. QuickSight is always adding new visual types to their capabilities as well. Some of the more recent ones include KPIs, or key performance indicators, geospatial charts, which are just, maps with dots on them like you see here, donut charts, gauge charts, and word clouds, and we'll dive into what these all are shortly. Here's a couple of bar charts. The one on the left is a somewhat typical horizontal bar chart. And this one's just trying to compare the human losses of World War II by country. So again, comparison, where you have a bunch of data points for different countries or whatever you have, and we want to see how they compare to each other. A bar chart is a very easy way to visualize that, where obviously the taller or longer bars in this instance correspond to the countries that took the heaviest losses. And in this case, we're actually plotting two different variants of that data together. So the red lines are the actual number of losses in millions, whereas the blue lines are the losses by a percentage of that country's population. So we can tell at a glance here that the country that lost the most of its population in World War II was Poland, but in terms of raw numbers, it was the Soviet Union. And it's pretty interesting how small the United States' losses are in all this thing. Really a sobering fact there. Histograms are also another important application of bar charts, and this chart on the right is an example of that. The idea of a histogram is that you bucket up your data into certain ranges. So in this example, we're bucketing up airplane arrival data by 30-second intervals here. So every one of these bars represents a range of arrivals per minute within, say, 4 minutes and 4 minutes and 30 seconds, or 5 minutes and 5 minutes and 30 seconds, and it's grouping all those together as a single bar. Okay, so a histogram is just a bar chart where each bar corresponds to a certain range of values that you want to plot. Line charts are appropriate for visualizing changes over time. So if you are trying to look for trends over time, usually a line chart is the answer. On the left, we have a simple one that's just plotting time versus speed for something. And on the right, we have a stacked area line chart there, where you're actually using different colors underneath the line to see how each data point on time breaks down. So if you have sort of 2 dimensions of data there, you can actually visualize that using colors underneath the line of your line chart as well. That's called an area chart. If you're trying to show the correlation between 2 different attributes of your data, a scatter plot might be a good way to do that. In this example, we're plotting the eruption duration from Old Faithful, which is a geyser in Yellowstone National Park here in the US, against the time between eruptions. So we can see, looking at this data, there's sort of a linear relationship between these 2 things. There is an actual correlation going on here. And you can often just draw a regression line through that data too to really make that more clear. But a scatter plot is a good way to show the relationship between 2 different sets of 2 dimensions of data, basically. In this case, eruption duration and the frequency of eruption. And we can see that there is a correlation between those values because those data points, when you plot them, seem to line up across sort of a straight line. You can also use heat maps to show correlation as well. This is an example of DNA microarray data reflecting gene expression values under several different conditions. And basically in the heat map, it's a 2D array of data, kind of like a scatter plot. The difference is that each cell is colored based on the value of the data in that cell. So we're kind of dealing with 3-dimensional data here. We have what gene it is, the conditions it's under, and then some other value reflecting that gene expression. So just by eyeballing this heat map, we can see something interesting is going on in the upper left-hand corner. We have this cluster of very light green values. And that might tell me that under these specific genes, under these specific conditions, something interesting is happening with those gene expression values. Everyone's seen a pie chart, I hope. These are just ways of visualizing aggregation. So if we have some sort of a whole that we're trying to see what different categories make a piece of, a pie chart is a reasonable choice for that. In this example, we're looking at the populations of native English speakers broken down by country. So out of all of the native English speakers in the world, we can see that most of them live in the United States, and the UK is a good chunk of that pie as well, followed by Canada, Australia, and everyone else. So pie charts, good choice for aggregation. Donut charts are very similar to pie charts. They're just a different representation. Generally, they're made to represent the percentage of a given thing to some total amount. So very subtle difference there to a pie chart. I've seen these used, for example, in revenue reports, where you have different things that generate revenue, and you want to see how much each thing contributes to the whole, the total of your revenue. In this silly example from the AWS documentation, they're doing sum of visits by planet. Not really sure what this represents, but I'm guessing it's like how many probes we sent to different planets in a given time period, maybe. So out of all the different space probes that we sent out, you can see that Jupiter made up the most of those targets, and followed by Mars and Uranus, and just a few going to Saturn, it seems. I don't think this is real data, based on what I know about space exploration. But anyway. So the documentation tells us that donut charts are best when your precision is not important. There's not specific values on this that you can look at, and there are a few items in the dimension. So, you don't want this to get too cluttered with too many things. So if you don't care as much about precision and you have just a few things that make up the sum of some whole, a donut chart might be the graph for you. We also have gauge charts, relatively new feature in QuickSight, and this allows you to compare values in a measure. Basically, it displays how much there is of the thing you are measuring. For example, fuel in a tank, or bandwidth usage out of your available bandwidth. If you've ever been to speedtest.net to measure the speed of your internet connection, you've probably seen a gauge chart. Same idea. Pretty simple stuff. It's a gauge. It allows you to measure how much of something you're using. And if you want to show aggregation with more of a hierarchical structure, tree maps are an option for that. This is kind of cool. So in a tree map, we have these sort of colored blocks that correspond to broader categories of exports for this country. And within each color, we might have sort of a hierarchical breakdown of stuff within that category. So, for example, that brown block at the top basically represents all of the metallic exports of this country, and that's broken down by iron bars of different types and scrap copper and raw iron bars and what have you. So that allows you to visualize data in a hierarchical way, whereas you have this sort of top-level view of different categories and then different rectangles within that view reflecting how that is broken down further within subcategories within that category. So if you want to do basically a hierarchical pie chart, a tree map is a way to do it. And for a pivot table, that's used for tabular data. And if you want to aggregate that tabular data in arbitrary ways or apply statistical functions to it, a pivot table is probably the way to do that. In this example, we have some raw sales data at the top, but we created a pivot table on the bottom that's pivoting on region and ship date, so we can view sales by region over time. So a pivot table is often a useful tool for visualizing trends or statistical functions on arbitrary dimensions of tabular data. KPIs, or key performance indicators, are a very simple visualization in QuickSight, but they're very important in the business world. It just allows you to visualize some key value that you care about compared to its target value. So if you have some goal for a metric, in this example, the forecasted monthly revenue, you can display how far along you are in that goal. It just has a little bar chart that says, here's my current value, here's where I want it to be, and here's the actual value itself. So pretty simple visualization, but it's a very common thing in the business world, so you should know what it is. Also, a relatively new feature in QuickSight is geospatial charts. So these are basically maps, and they allow you to plot, the distribution of things across a map that you can zoom into and out of. Some of pop by statement charts. I'm not really sure what that's supposed to represent, but you can see that quantities associated with a location are represented by different circles of a different size. So the size of these circles represents the quantity associated with different cities, or states in this case, and the colors are just used to separate them. So that's what a geospatial chart is. It just allows you to localize data on a map view, and you can interactively move around that map and zoom in and zoom out to visualize the distribution of your data geographically. You've probably seen word clouds before. They just display the word or phrase frequency. Basically, the size of a word or phrase represents how often it appears in a set of documents. So popular midweek destinations. Maybe you have some data set of people that have traveled to different places, and this can be used to visualize what the most popular phrases are within that data set. In this case, it turns out that Atlanta is a popular place to go during the middle of the week. More typical examples might be visualizing text data and how that is distributed. I have one example in Elasticsearch, for example, where we look at the entire works of William Shakespeare and use a word cloud to visualize what phrases come up the most often within the works of Shakespeare. In that example, it turns out the word exeunt, which means exit, is the most common word. So that's what a word cloud looks like in QuickSight, and they are best used when, again, precision is not important and you don't have a large number of distinct values, kind of like, a donut chart. They work best if you don't have too many words and phrases that will clutter things up, and you don't really care about precision because all you're using is the size of the word to gauge how important each word or phrase is. So let's take a really quick look at Amazon QuickSight. That is the last piece of our puzzle here in building out our data warehousing and visualization requirements for Cadabra.com. So all we're going to do is spin up Amazon QuickSight, look at a couple of graphs that are coming out of Amazon Redshift, which in turn is looking at our order data in Amazon S3, just so you can see that it does in fact work. And with that, we've actually built out our entire system once we're done with QuickSight. So moving on, we've actually built this whole thing throughout this course. I mean, that's pretty cool. You've done a lot of work in this course, so congratulations. You should feel good about that. We started with a bunch of order logs on our servers and HTTP access logs, and we published that and analyzed it in many different ways. We pushed it out through Data Firehose to the Amazon Elasticsearch service, also directly into an S3 data lake. From there, we actually performed machine learning on it. We actually queried it through AWS Glue and Amazon Athena. We analyzed it to produce recommendations using Amazon EMR, and we've also put a Redshift data warehouse on top of that data, and now we're about to query it and visualize that data using Amazon QuickSight. We've also gone ahead and built out this really cool application that notifies us through cell phone text messages whenever an order rate passes a threshold, and we've also used Amazon Lambda through Kinesis data streams to pump that data into DynamoDB, where we could actually access it from an end user's mobile client if we wanted to. So we've built a lot of stuff here, guys. It's pretty cool. And it wasn't actually that hard, right? AWS makes this easy. That's the whole point. And in a scalable and reliable manner. So enough of that. Let's start playing with QuickSight. So back to the console here. Let's just type in QuickSight. Now, QuickSight is a subscription-based plan that's sort of in addition to AWS, so we're going to have to sign up for a free trial of it. So our account is not signed up for QuickSight. Let's go ahead and sign up. Just make sure that you don't renew it when the trial is up, and it wouldn't cost you anything. Standard is fine by us. We're not going to be doing much with it at all here. And hit continue. So we need to fill out a few forms here. Let's give our account a name. I don't call it Cadabra for lack of a better idea. You will need to put in your email address. And select your region, auto discovery, fine, Athena, good. We also need to enable Amazon S3. And we need to select which buckets we want to use here. That one's the one that we're interested in. For you, it'll be order logs, something else, of course. And that should do the job. Hit finish. You can see QuickSight is kind of different from other AWS offerings. You know, it's very much geared toward end users and not developers. So it's a very different experience here, you'll see. It's much more like signing up for a software as a service sort of a thing, a remote platform as opposed to an actual developer tool. All right, we're already signed up, so let's go ahead and go to Amazon QuickSight. And it even walks you through a tutorial here if you want. But let's skip all that and just click on New Analysis instead. Let's click on New Dataset. Let's go ahead and connect it to Redshift. It auto-discovered our Redshift server, it seems. Let's call it Cadabra Orders. We'll choose our Cadabra Redshift cluster. The database name is dev, username is AWS user, and whatever password you set up previously. Create data source. All right, apparently we were having trouble connecting to it, and it's just trying to connect to it through SSL. So I suspect the issue is that we'd locked down SSL earlier to our Redshift cluster to our own IP. So let's go and open that up more widely for now. Let's go back to the AWS console. Sign in. Go back to the VPC dashboard and go down to security groups. Let's edit our Redshift security group there. Inbound rules, edit, and let's open up port 22, shall we? Okay, so we've gone ahead and opened up our Redshift cluster to the world here. That may or may not make sense depending on how widely you intend to open up your QuickSight dashboards to the world. But we're only just experimenting here for a few minutes, so we'll go with that for now. And now let's see if we can connect it this time. Let's click the Validate button here. All right, now we're up and running. So let's go ahead and hit Create Data Source. And we can select our tables here. We want the order log schema. And we want the order log sundog or edu or whatever you called your bucket to visualize. Select that. Okay, let's go ahead and let it import that data into Spice. As you recall, Spice is a feature of QuickSight that imports things into memory for quicker analysis. And let's click the handy dandy Visualize button. And now we can just play around with the data here interactively, whatever you want to do. So we can just start by clicking on some field that we're interested in visualizing. And the cool thing about QuickSight is that it kind of tries to read your mind and give you useful graphs just automatically. So let's say I'm interested in invoice date. Automatically, it's going to give me a count of records by invoice date. So we can see this graph here showing how many orders I get broken down by time. And I didn't have to do much of anything. I just had to click on invoice date and it just did it. So that's kind of the power of QuickSight. It can be very intuitive. Let's also click on, say, a country. And now we can combine these fields together, and it automatically selected an appropriate visualization type here that's breaking down count of records by country and invoice date. And we can see already that we have some data quality issues, right? So apparently some things are in the invoice date column that shouldn't be. So I don't think Magic Garden and Sugar Jars are actually dates. So again, half the battle in data analysis and data science is cleaning your data. Obviously, this data set has some cleanliness issues that need to be dealt with here. But that aside, it does actually work if you break this down by time and date. So that's kind of neat. Here's another neat thing we can do. We can click the capture button to sort of take a snapshot of this graph. Let's say we want to kind of like make a presentation and tell a story about something using several different graphs that we put together. I can capture this graph using the capture button and put it into a storyboard. So by doing this, I can play back a story that just lets me flip through multiple different graphs as part of a larger presentation that I might give in a meeting or something like that, right? Let's go back to Visualize and let's just click on Description and nothing else. You can see we actually got some pivot tables when we had more than 2 columns there. So this is actually breaking down orders by product, which we've done before, just in a more visual manner. So pretty cool. And you can see that does in fact work. Again, we can hit capture again if we wanted to make that another part of our little story there. And here, now we have a nice little storyboard. We could rename it, and it has those two graphs that we just created in there that we could play back if we wanted to. So that's QuickSight in a nutshell. As far as the exam's concerned, all you really need to know is how this is intended to be used, and you've seen that now, and what some of the different visualization types are. Even though it does choose automatically for you, you can specifically choose different visual types as well, and you need to have some knowledge of just what kind of graph is useful for what kind of problem. So that's sort of a separate problem of itself, but it's a good idea to go through all of these and make sure you understand what these graphs are and how they're used. If you want to play with them interactively, you can. Scatter plots are going to show up. Pivot tables are going to show up. Pie charts are going to show up in the exam. Line charts. You just have to know what they are and how they're used. Okay, so that's QuickSight for you. Let's make sure that you're not going to get billed for this, guys. So go up to your account, which is here. Manage QuickSight. Go to your subscriptions. And just make sure auto renewal is off. That way you can be sure that you're not going to get charged for this. And you actually have, I have 61 days remaining on my free trial, so you have plenty of time to mess around with this if you want to for free. Just make sure you're not auto renewing it so that you're not going to get billed unexpectedly. All right, so we are actually done with everything at this point. We're done with Redshift, and Redshift does cost money. So let's make sure we go back and shut down Redshift, right? Back to the console. Sign back in, go back to Redshift, select our cluster, go to the cluster dropdown and say delete cluster. Now we don't care about this data, so we're just going to say no for the snapshot. If you wanted to, you could automatically dump a snapshot of that data at S3, so you could recover it later if you wanted to. I don't care though. I will acknowledge that once I delete this cluster, the data is in fact gone forever. It isn't really though, because it's actually housed in S3, right? So there's really nothing to worry about here. Delete. And that way we will not get charged for our Redshift cluster either. And at this point, you should make sure that we're shutting down everything that we don't care about. If you're done with the course at this point, let's go back to EC2. I actually want to keep playing with this myself, but if you are in fact finished, you can go to your instance here and actually terminate that as well. You can just select the instance here and go to Actions, Instance State, Terminate. And that will make sure that your EC2 instance gets killed as well. So yeah, just clean up anything that might be outstanding here to make sure that you're not going to get any unexpected billing going on. And at that point, yeah, we've built out the whole thing. So congratulations, guys. We have imported data using Kinesis in a variety of ways into, among other things, an S3 data lake that we have analyzed using Redshift, Athena, and QuickSight. So congratulations again. Finally, you'll also find it helpful to be familiar with web-based visualization libraries and how they compare to QuickSight, even though these have nothing to do with AWS. In each case, these are front-end JavaScript libraries that rely on data provided by your web server. So you might be hosting data through an EC2 instance or something, and your web front-end is actually consuming that data and producing visualizations on top of it. One such package is D3.js. D3 stands for Data-Driven Documents. D3.js is a JavaScript library which is used for manipulating documents based on data. It's a dynamic, interactive, and online data visualization framework. There's no standard visualization format for it, but it works with web standards such as HTML, CSS, and SVG. It claims to be lightweight, fast, and works with large data sets. There's also Chart.js, which is a community-maintained open source library, which helps you easily visualize data using JavaScript. It supports different chart types such as bars, lines, pies, and so on. There's also HighChart.js, which is another JavaScript-based charting library. It is interactive and provides interactive charting capabilities to your web applications, including line charts, spline charts, area charts, bar charts, pie charts, all the likely suspects. So these are all JavaScript libraries intended for use on a website that can sit on top of data provided by some backend server. A little bit different from QuickSight in that this is really intended to be deployed to the public. It's not intended to be deployed to users of your organization or people within your organization. This is meant for a website that's deployed to the world. So that's the main distinction here. If you want a visualization tool that is internal to your organization but is yet still highly scalable, QuickSight is the right choice for that. But if you actually want to publish data to the entire world on your public-facing website, you probably want to use some sort of a JavaScript library like D3.js, Chart.js, or HighCharts. Also, there are other visualization tools out there for internal use as well, including Tableau and MicroStrategy. These are both competing business intelligence tools, and usually they can integrate with any JDBC or ODBC database on the back end. So this is something you might use on top of Redshift, for example, a viable alternative to QuickSight. But QuickSight kind of fills that same space. And that's it on visualization tools. A pretty short section here. There's not a whole lot to talk about because really it comes down to QuickSight in the AWS world. In addition to that, they are also going to ask you about different ways of visualizing and how to choose the right kind of chart or graph. And you at least need to know what these alternative tools are and how they might fit into a larger solution and how they compare to QuickSight.